Okay, so today's Algebra 2 lesson 2.6, the quadratic formula. We're going to look at how we can use the quadratic formula to solve quadratic equations or to predict the nature of the solutions. Today we're going to focus on using the quadratic formula to solve equations. So remember that if you cannot factor a quadratic equation and you don't want to complete the square to make it factor, you can always use the quadratic formula to solve the quadratic equation. And remember, when we say to solve the quadratic formula, we are talking about finding the zeros. So recall from Algebra 1, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. I don't know what happened to our c right there. There is a c. Recall that the a, b, and c come from ax squared plus bx plus c. Right? So we're going to solve using the quadratic formula. The very first thing that we want to do, make sure that everything is on the same side and it's set equal to 0. Then we can identify a, b, and c. So in this problem, a is my 3, b is negative 4, and c is negative 9. So we're simply going to plug those in. So x equals negative b, that just means change the sign of b. My b was negative 4, so I make it positive 4. Plus or minus the square root. Negative 4 squared minus 4 times 3 times negative 9, all of that divided by 2 times 3. So when I simplify what's underneath my radical, so I have 4 plus or minus the square root, negative 4 squared is 16, negative 4 times 3 is negative 12, negative 12 times negative 9 is plus 108, everything divided by 6. So again, x equals 4 plus or minus, so underneath my radical, 108 plus 16 gets me 124. Everything over 6. Now I need to look at the square root of 124. That is not a perfect square, so I want to ask myself, can I do factor tree on it? So factor tree on 124, what can I multiply together to get 124? That's 4 and 31. 4 breaks down to 2 and 2. So x equals 4 plus or minus 2 square roots of 31, everything over 6. We always want to put our answers in exact form, so no decimals allowed when we do quadratic formula. So now I notice I have a 4, a 2, and a 6. I can reduce all of those by 2. So I get x is equal to 2 plus or minus the square root of 31, everything over 3. So this is the same thing as saying x equals 2/3 plus the square root of 31 over 3, and x equals 2/3 minus the square root of 31 over 3. We need to recognize that all of those are the same thing. We will always have the two answers, plus or minus. All right, let's look at example number 2. X squared minus 9x plus 27. Again, I'm looking at, can I factor this? What could I multiply together to get 27, but add or subtract to get negative 9? Nothing. So if we didn't want to factor, okay, by completing the square, then we would do quadratic formula. So we would identify a, b, and c. So a is 1, b is negative 9, and c is 27. And then we just plug those numbers into the formula. So x equals 9 plus or minus the square root 9 squared minus 4 times 1 times 27, everything divided by 2 times 1. And again, let's simplify what we have underneath the radical. So 9 plus or minus, so the square root of 9 squared gets me 81. 4 times 1 is negative 4. Negative 4 times 27 minus 108, everything divided by 2. So I have 9 plus or minus, so underneath my radical, 81 minus 108 is negative 27, everything over 2. So now we want to do factor tree on 27. I know that that is 9 and 3. 9 breaks down to 3 and 3, so I have a pair of 3's that are going to come out. So I get x equals 9 plus or minus, so the 3 came out, but remember this was negative 27 underneath the radical. Anytime I have a negative underneath the square root, that always comes out as an I, so we're going to be dealing with complex numbers here. So plus 3i square roots of 3, all divided by 2. I have a 9, a 3, and a 2, nothing in common, so that is my answer, or I could write this as 9 plus 3i square roots of 3 over 2. And this equals 9 minus 3i square roots of 3 over 2. Or again, I could separate those fractions and make it 9 halves plus 3i halves divided, or sorry, times the square root of 3. All right, let's go down to number 3. 3x squared plus 6x plus 3. Again, identify A, B, and C. A is 2, B is 6, C is 3. X equals, so negative B, so negative 6, because I changed the sign of my B, plus or minus the square root of 6 squared minus 4 times 2 times 3, everything divided by 2 times 2. So we get x equals negative 6 plus or minus, underneath the radical, 6 squared is 36. Negative 4 times 2 is negative 8. Negative 8 times 3 gives us negative 24. All divided by 4. So combine like terms underneath the radical. 36 minus 24 gives me 12. Do factor tree on 12. 4 and 3. 4 breaks down to 2 and 2. So I get x is equal to negative 6 plus or minus 2 square roots of 3, everything divided by 4. I have a 6, a 2, and a 4. They all have a 2 in common. So if I simplify that, you always want to reduce as much as possible. So we get x equals negative 3 plus or minus the square root of 3, everything divided by 2. And again, we need to recognize that that is the same thing as saying x equals negative 3 plus the square root of 3, all that divided by 2. And x equals negative 3 minus the square root of 3, all of that divided by 2. All right, number 4. 3x squared minus 2x plus 7. Okay, so again, identify A, B, and C. A is 3. B is negative 2. C is 7. X equals 2 plus or minus the square root. Negative 2 squared minus 4 times 3 times 7. Everything divided by 2 times 3. So x equals 2 plus or minus the square root of 2 squared is 4. Negative 4 times 3 is negative 12. Negative 12 times 7 is negative 84. All over 6. So I have 2 plus or minus. So when I combine like terms, 4 minus 84, I get negative 80 over 6. I need to do factor tree on negative 80. So 80 I can break down to 10 and 8. 10, 2, and 5. 8, 2, and 4. 4, 2, and 2. I have a pair of 2's here and a pair of 2's here with 5 left behind. So I get x equals 2 plus or minus. I had 4 that came out. I had that negative underneath the radical. So again, that comes out as the I. Square root of 5 left behind. Everything over 6. I have a 2, a 4, and a 6. They all have a 2 in common. So simplify that. Okay. 2 divided by 2 is 1. Plus or minus 4i divided by 2 is 2i. Square roots of 5. 6 divided by 2 is 3. So those are our 2 answers. Again, recognizing that I could separate them. Okay, let's go to the back. Here we're going to solve using 2 different methods and then tell which method you prefer and why. So the first method that we'll do, quadratic formula, because that's what we've been doing. Right? So here we're going to do quadratic formula. So if I do quadratic formula, A is 6, B is negative 7, C is negative 20. So I get x equals 7 plus or minus the square root. Negative 7 squared minus 4 times 6 times negative 20. All divided by 2 times 6. So I get 7 plus or minus. I'm going to go ahead and combine everything underneath my radical. So 7 squared gives me the 49. And then 4 times 6 times 20, 480. When I add those together, I get 529 here. Everything divided by 12. The square root of 529, that is actually a perfect square, so I can work that out. So x equals 7 plus or minus. So the square root of 529 is actually 23. All of that divided by 12. Very important. We cannot leave our answer like this. We have to work this out. Okay, so I have one answer. It's going to be 7 plus 23, and then I'm going to divide by 12. My other one is going to be 7 minus 23 divided by 12. Okay, so if I do 7 plus 23, I get 30 divided by 12. It's not a nice whole number, but I can simplify that. They both have a 6 in common. So 6 goes into 35 times. 6 goes into 12 twice. So my first answer, 5 halves. When I do 7 minus 23, I get negative 16 over 12. Again, not a nice whole number, but I can simplify that. So 16 and 12, they both have a 4 in common. So I end up with negative 4/3. Those are my two answers. All right, so now let's work at another method. Let's try to factor. So if I want to factor this, 6x squared minus 7x minus 20, I can do 6x squared times negative 20, right? So 6x squared times negative 20 gets me negative 120x squared, and then my middle term is a negative 7x. So I'm looking for what can I multiply together to get negative 120x squared, but add to get negative 7x. So negative 15x and a positive 8x. Negative 15 times 8 is negative 120. Negative 15 plus 8 is negative 7. So I'm going to factor this by grouping, okay? So I would rewrite this. I've got 6x squared plus 8x minus 15x minus 20 equals 0. So remember, I just rewrote that negative 7x as 8x minus 15x. So now I'm going to group the first two terms together and the second two terms together. Now I'm looking at GCF. So what do 6x squared plus 8x have in common? They have a 2x in common. So if I factor out a 2x, which just remember means divide, I end up with 3x plus 4. I have a negative 15x minus 20. Remember, if that first number is negative, I always have to pull a negative out. So negative 15 and negative 20, I can pull out a negative 5. So if I divide out a negative 5, I'm left with 3x plus 4. Did I get the exact same thing in parentheses? Yes, I did. I know that I factored it correctly. So that's my first factor, 3x plus 4. My second factor, I combine the GCFs I took out. So 2x minus 5. All of that equals 0. So is equal to 0, right? 3x plus 4 equals 0. 2x minus 5 equals 0. So when I solve this first one, I get x equals negative 4/3. X equals 5 halves. Did I get the exact same answer as I did when I solved my quadratic formula? Why, yes, I did. Which one do you prefer? I prefer factoring. Why? Because I think it's quicker and less work. Let's try another one. Okay. Again, we're going to do both methods. I'm going to factor first. So first I'm going to try to factor this one. 6x squared plus x minus 15. So multiply 6 times negative 15, and I get negative 90x squared. My middle term is a positive x. So what can I multiply together to get negative 90, but add to get positive 1? That would be a 10x and a negative 9x. 10 times 9, 90. 10 plus negative 9 is 1. So I'm going to rewrite this. So 6x squared minus 9x plus 10x minus 15 equals 0. So I just rewrote the positive 1x as negative 9x plus 10x. Group the first two and the second two terms together. Take out your GCF. So 6x squared minus 9x. I can take a 3x out. And I'm left with 2x minus 3. Negative 10x minus 15, that's plus 10x minus 15. I can pull a 5 out, and I'm left with 2x minus 3 equals 0. Again, I got the exact same thing in parentheses, so I know I factored it right. So 2x minus 3, that's one factor. And find the GCFs I pulled out. 3x plus 5, that's my other factor, equals 0. Set these both equal to 0. And solve. So here I get x equals 3/2, and here I get x equals -5/3. Those are my two answers. Okay, let's do quadratic formula again over here. So if I'm doing quadratic, I need to identify a, b, and c. A is 6, b is 1, c -15. X equals -1 plus or minus the square root 1 squared minus 4 times 6 times -15. Everything divided by 2 times 6. We get x equals -1 plus or minus. Again, I'm going to work out everything underneath my radical. So 1 squared is 1. -4 times 6 is -24. -24 times -15 is positive 360. So when I add those together, I get 361. All divided by 12. This is a perfect square, so I get -1 plus or minus. When I take the square root of 361, I get 19 divided by 12. Again, we cannot leave our answer like that. We have to work it out. So this is really -1 plus 19 divided by 12. -1 minus 19 divided by 12. So here I get 18 divided by 12. Which will simplify. So 18 and 12, the biggest number that they have in common is 6. So that simplifies to 3/2. There's my first answer. Over here, -1 minus 19 gets me -20 divided by 12. -20 and 12, the biggest number that they have in common is 4. So 4 goes in here at -5. There's my answer. Again, which method do I prefer? I still prefer factoring because it is quicker and less work. All right, that was the first half of section 2.6 quadratic formula. Tomorrow we'll look at the discriminant and how we can use the discriminant to determine what types of solutions we will have.